Dear students, today we are discussing the properties of arithmetic mean. We have discussed the definition of arithmetic mean and we have considered some problems. So I think you got the idea of how to find the arithmetic mean of a raw data and a class frequency data. Okay, so today we are discussing two properties that are very important. And the first one is algebraic sum of the deviations of a set of observations from their arithmetic mean is 0. Let us consider a data and then take the algebraic summation of deviations from the arithmetic mean. So what is the algebraic sum of deviations of the data from the arithmetic mean? Yeah, suppose there are n observations. Okay, so what is deviation? Deviation is exactly equal to xi minus x bar. So deviation from arithmetic mean means xi minus x bar. Okay. So this is exactly deviation. Okay, and sum of the deviation. So that will be equal to, you know that we can take the summation to both sides. So it will be I equal to 1 to n xi minus again summation I from 1 to n one x bar. Okay, so that equal to so what is this? This one is again summation of, let us take the copy and substitute here. So this is exactly n times x bar, n x bar. Okay, n x bar, because summation is taken over I, so this will be n x bar. Okay, so that equal to, again we can substitute this one. So what is summation xi? You know summation xi by n is exactly equal to, what is that? Summation xi is nothing but n x bar. Okay, minus already there n x bar is there, so summation xi is n x bar. Okay, here also we have x bar. So what is n x bar minus n x bar? This is equal to 0. So for the raw data, algebraic sum of deviations of the observations from the arithmetic mean is 0. Now we consider the case of frequency data. How can we find out the result using frequency data? Yeah, it is very simple. You can easily find out the similar result for the frequency data. So what is exactly for the frequency data? Okay, for the frequency data, summation I from 1 to n fi this will be summation fi into xi minus x bar, that equal to summation fi xi minus summation I from 1 to n fi x bar. This is nothing but summation I from 1 to n fi xi minus, but you know that x bar can be taken outside, and then summation fi. What will be summation fi? Yeah, we can put we can take x bar outside and put summation here. Okay, so what is summation I from 1 to n xi, fi. Okay, so that is exactly equal to, this is exactly equal to n into x bar, capital N into x bar, and this is nothing but x bar is already there. me go back. Okay, let us put the summation here. Because this x bar should come here. Okay. X bar is taken outside, and the remaining term is I equal to 1 to n fi. So this is exactly equal to capital N into x bar. Okay, from the definition of frequency, mean of the frequency data, it is nothing but capital N into x bar. And the second part is, what is the second part? Yeah, this is exactly equal to summation fi is capital N. Okay, so this is again 0. So this is the step given here. Okay, so we can easily see that since x bar is equal to summation I from 1 to n fi xi by n, summation fi xi equal to n x bar. Okay, for the frequency data, what is capital N? Capital N is summation fi. So instead of summation capital Fi, we can put n, and instead of this term, this first term, we can put n into x bar like this. Okay, n into x bar. So from that we can easily see that it is exactly equal to n x bar minus x bar n, that is exactly equal to 0. Exactly equal to 0. Okay. So this is a property. What is the property? The algebraic summation of deviations of the observations from the arithmetic mean is 0. This is for the raw data, this is for the frequency data. Okay, so that is given in this page 2.9. Okay, the book of fundamentals. Another property is very interesting property, and you can easily understand the concept using mathematical differentiation technique. You know what is the maximum and minimum of a function? Can you find out maximum and minimum of a function? How can we find out maximum and minimum of a function using mathematical techniques? So I think you might have studied differentiation technique for finding maximum or minimum. So what is the technique? The function, we can differentiate the function. If the function is differentiable, we can differentiate the function with respect to the variable, and if the derivative is equal to 0, if the derivative is equal to 0, what is derivative? Derivative equal to 0 means the slope is parallel to x-axis. In that case, we can say that the df by dx, or derivative, first derivative of the function with respect to the variable is 0. In that case, we can say that the point at which the derivative becomes 0 is either maximum or minimum. Okay, I'll give you an example using some figures. Okay, let us wait for some time because it is coming down. So our aim is to find out what is the property. The sum or square of deviations of a set of values is minimum when taken about mean. So we can take either mean or median or mode or any other constant. Okay, we can take the deviations of the observation from mean or median or mode or from any other constant. So the square of the deviations it will be minimum only when we take the deviation from mean. So that is the result. The square of the deviations will be minimum only when we take the deviation from the mean, about the mean. Okay, so let us consider, I shall show you for the raw data. So what is the result says? Yeah, suppose we are taking the sum or square of deviations. Okay, yeah, this is exactly sum of square of deviations. Okay, this is square of deviation. Okay, that will be minimum only when, so minimum means the least value will be attained only when we use x bar, x minus xi minus okay. So this is the result. The sum or square of deviations of the observation will be minimum when we take x bar, the deviation, when we take the deviations from x bar, arithmetic mean. So if we take median, it will be greater than the sum or square deviation based on mean. So sum or square of deviations of the observations will be minimum when we take the deviation from the mean. If we take a, median or mode or whatever be the constant we are using instead of a, so the sum or square of the deviations from that constant will be greater than the sum or square of deviations of the observation from the mean. Okay, so that is the idea. So how can we obtain this result? Yeah, we can use the differentiation technique. For that, let me show you some figures from the Google. Okay, yeah, we can see the two figures here. These two figures here. One is having minimum value and another is having maximum value. Okay, the maximum value is clearly defined here. It is the minimum value. It is the maximum value. So what is the speciality of this minimum and maximum? What is the speciality of minimum and maximum? Yeah, think about this figure. In this figure, the slope, this is a slope. These lines are slopes. Okay, so here at the point C, the slope is positive. Okay, at the point D, the slope is negative. Okay, decreasing. But at the point A, the slope is parallel to x-axis. What is slope? Slope is nothing but dy by dx or df of x by dx. Okay, so also in the case of minimum, you know that at the point E, the slope is negative. At the point F, the slope is positive. And at the point B, the slope is parallel to x-axis. Okay, so you can see that the slope will be 0 when the curve attains its minimum or maximum. In both cases, we can have that slope equal to 0. But to verify whether this is minimum or maximum, that means we have two options. If slope is equal to 0, we have two options, that is either minimum or maximum. So we have to just verify whether this is maximum and this is minimum, or the point at which first derivative equal to 0 is maximum or minimum. So that criteria is given using second derivative. If the second derivative is positive, then the point will be point of minimum. Okay. If the second derivative is less than 0, the point will be maximum. So what is the criteria? Yeah, to find out the to find out the maximum or minimum, first we have to differentiate the function if it is differentiable with respect to the constant, and if it is equal to 0, then the point A will be either A is maximum or minimum. Okay, maximum or minimum. Maximum or minimum. And then to verify whether this is maximum, we have to verify whether the second derivative, okay, the second derivative is positive or negative or positive. So let us go to the second derivatives, d square f of x by dA square. dA square. If it is less than 0, it is A is a point of maximum. Okay, if it is less than 0, the point A is a maximum. Okay, if it is greater than 0, the point is A is a minimum. So this is the idea. This is the mathematical idea we are adopting for finding the point of minimum or maximum. So let us consider the function z in terms of A. Z means set of A. Okay. Yeah, let us consider this is in our text, it is denoted as z of A. Okay, z of A equal to this one. Let us remove this part. This is not required now. So z is a function of A. We can treat z as a function of A. Okay, here also we are considering frequency, or first of all we can consider raw data. Okay, z of A equal to summation I from 1 to n xi minus A square. Okay, let us differentiate with respect to A. What happens? Yeah, next step would be, sorry, d by, can you say? Oh, you are not here. So let us differentiate this set of A with respect to A. So d is set of A by dA. Okay, what happens? We can again put this differentiation here. Okay, what will be the result? D of the divided by d of A. So this is the okay. So what will be the next step? Let us put it here. Yeah, what will be the result? After differentiation, we can remove this part to here. Okay, and put here. And what will be the next step? Yeah, it will be 2 times summation I from 1 to n dxi minus xi. We can remove this 2. Okay, and derivative of this one with respect to A. What is that derivative? That will be minus 1. Okay, into minus 1. So we can take this minus 1 outside, and 2 outside, 2 already taken outside. So what will be the result? Minus 2 can remove all these things. Okay, minus 2. Okay, so what is sorry, we can remove this term also. We don't want this one because we have already differentiated that with respect to a. So this is exactly equal to, so what is this? Yeah, we can put x bar inside. So okay, so this is the step. Okay, okay, there is no x because when we differentiate with respect to, yeah, when we put this, yeah, this is sufficient. Okay, now we can say that dz by dA equal to 0. So what happens? Dz by dA equal, so this is only a simplification. Now we move to the next step, that is dz by dA equal to 0. Equal to 0 implies, what implies? Yeah, we can remove all these steps. This is equal to 0. Okay, because the right hand side of that is, this is equal to 0. Sorry, equal to 0. Okay, this is equal to, this 0 means we can move this minus 2 to right side, so it will merge with 0 and implies, this implies what will be the result? This implies, we have to, yeah, this is equal to 0. Okay, that implies yeah, this can be taken, this can be considered as a, this can be considered as n times a. Okay, n times a. When we take the summation inside, bracket n times a equal to 0. That means what is the, what it means? Yeah, that means a equal to a equal to a equal to by n. Is it right? A equal to summation I from 1 to n xi by n. Okay, so that is exactly equal to x bar. So the point of minimum is, minimum or maximum is x bar. Now how can we verify the second derivative is greater than 0? So let us take the second derivative of this function. Okay, z of a. So what will be the second derivative of z of a? Second derivative of z of a will be let us put the square now. square will be we need not to consider all these terms. We need only consider this one because we have the simplified form. So what will be the second derivative? D by input derivative of derivative d by dA of x minus a. So that is exactly equal to minus 2 into minus 2 into, so what is this? What is the derivative of this one? Minus 1. Okay, minus 1 is added up to I from 1 to n. So what will be that? Minus n. Okay, so minus and minus will get cancelled and the result will be 2n, that is greater than 0. Okay, so we obtained that second derivative d square z by dz square dA square equal to minus 2 into summation I from 1 to n d by dA of xi minus a, that equal to minus 2 into minus n, that equal to 2n greater than 0. So we obtained we verified that at the point x bar, okay, at the point x bar, this second derivative is negative because we obtained a equal to x bar. So x bar will be the point of minimum, okay, for this function z of a. What is z of a? Z of a is the sum of square of deviations of the observation from the arithmetic mean. So similarly we can prove the result for frequency data. What is the step? The step is given here. You know that you consider this z as, I am not writing again, we can consider z as summation I from 1 to fi into xi minus a square. So just to take the derivative dou z by dou a, that we can consider the entire function again with the frequency data. Okay, dz by dA equal to fi into xi minus a square, that equal to fi into xi minus xi square, that equal to fi into minus 1 is remains there, so that is fi into this one. So dz by dA equal to 0 implies that minus 2 into fi xi minus a equal to 0, that implies minus summation I from 1 to fi into xi minus a equal to 0, that implies summation fi xi equal to not small n a, it is nothing, it is exactly equal to capital N a, because the summation the next step we can write one more step here. Since it is a frequency data, we can incorporate one more step. What is that step? Yeah, we can put I equal to 1 to n f5, and a can be taken outside. A can be taken outside. So this is not required. One bracket is there. Okay, equal to 0. That means, so this is exactly equal to, what is that? Yeah, this is actually n. Okay. n. Okay. Bracket distance an. Okay, so from this a equal to summation I from 1 to n capital N into fi xi, summation I from 1 to n that is nothing but x bar. So in this case also we can find we obtain that a is equal to x bar. So the differentiation after differentiation we can see that the point of minimum or maximum is a equal to x bar. So now we verify whether this point is maximum or minimum. For that we will take the second derivative and we can see that this is minus 2 into summation I from 1 d by dA fi xi minus a, that equal to minus minus 1 into minus 1. Okay, only minus 1 comes there, but we have to put a summation there. Okay, we can put the summation equal to 1 to n fi into minus 1. Okay, so what is that? Yeah, minus 1 minus get cancelled. The summation of phi is nothing but capital N. Summation of phi is nothing but capital. So 2n, that is greater than 0. So in this case also we obtain that d square z of a by dA square is greater than 0. Two result. We obtain that using this equation. Using this equation, we obtain the change point, that is either minimum or maximum, and we have verified that the point at which a equal to x bar, f of the point at which d z of a by dA equal to 0, that means a equal to x bar is point of minimum, because the second derivative of z of a with respect to a is positive. Okay, so that is clearly mentioned here, and I will send to you this file, and you can write down from this, and using that book also you can write down the result clearly. And if you have any doubt, you can ask me, no problem. I am ready to clarify your doubts. And the file name is minimum. I will send you, no problem. You can see again this video. I will share this video using this Moodle platform. Okay, thank you very much.